Okay, today we're going to be working out of 6.6, and we're going to just kind of put everything that we've been doing together in Chapter 6 and finally just solve any radical equation that we want to and not worry too much about all these little rules. They're pretty much going to be in line with things that we've already learned, and we're just going to follow through the normal process of solving. We just have to realize that when we solve, we're going to go through PEMDAS in reverse, and then as we go through it in reverse, that with our exponents are also going to be our radicals. And so if you think about this square root of x, it's also going to be like x to the 1/2, which is an exponent, so we're going to treat those the same. Which means I won't handle that square root until pretty late into the solving process. Alright, so to get started with a problem like this, I need to do any addition subtraction in the problem, and I notice that there's a -6 here, so I'm going to add 6 to both sides, leaving me with -4 times the square root of x equals -14. That's all of my addition and subtraction. Now I notice there's multiplication division to deal with, so I'll divide by -4 to get the square root of x is equal to -7. So this is going to negative and negative will cancel, 7/2 when we reduce. And so now I want to get rid of this square. Well, the opposite of a square is a square root, or opposite of a square root is a square. So those will take care of each other, leaving me with x equals. Now when I square this right-hand side, I want to be sure to square the numerator and the denominator. Well, 7 squared is 49, and 2 squared is 4. And that's great. 49/4 is definitely an acceptable answer. 30. A similar process. We look at this, we see the exponent, we know everything else is out of our way. What I notice is that I've got a 5/6. Now that means I need to undo a 6th root, and I also need to undo raising this to the 5th power. Even if I got rid of the 6, if I left the 5 here, this would mean I have to write this out 5 times, FOIL it together, and try to work with it. That's a disaster. And so what I'm going to do instead is I'm going to multiply or evaluate both exponents to its reciprocal. And this is 32 to the first, and I'm going to multiply by 6/5. Now this is going to cancel to leave me with 5x minus 19. So by using the reciprocal, I've eliminated the exponent. Now I have to do 32 to the 6/5. Well, in my calculator, that's easy to evaluate. And so I'm going to throw all that together. I think I'm going to end up with 64, but let's check just to make sure. Yep, I'll end up with 64. Again, 32 raised to the 6/5, because 1 times anything is itself. So I'm going to get 6/5. So I get 64 here. I'm going to add 19 to get 83. 5x equals 83. And then I'll divide by 5 to get 83/5. Perfect. Pretty straightforward, really. Not a lot of work. Starting in 34, though, it changes just a little bit. And this is going to have a 3-step process. From 34 on, our first step is to isolate a radical. We need a radical that's by itself. Well, I've already got that. That was handed to me. The second step is to insert parentheses. Well, this is all ready to go. This side needs some parentheses around it. And then my third step is to square and FOIL. So I need to square both sides to get rid of this square root. And squaring on the left side produces a FOIL. So x minus 6 times x minus 6 equals 3x. Well, through the distribution, I'll get x squared. I'll get minus 6 and minus 6x. That's minus 12x. And then -6 times -6 is positive 36 equals 3x. I always want these to equal 0, so I'll minus 3x to get x squared minus 15x plus 36 equals 0, and then I'll try to factor. It'll give me x and x. My signs are the same and negative, so negative, negative. Factors of 36 that add up to 15. I'm thinking of 3 and 12. which tells me that x could equal 3 or it could equal 12. Unfortunately, when I squared this, I ended up with losing the identity of positive or negative. Just a second. Sorry about that. So it's possible that one of these or both of these might not work, and so I need to check both of them against the original problem. The original problem is x minus 6 equals the square root of 3x. So I'm going to evaluate both versions. I could have 3 minus 6 equals the square root of 3 times 3. This is 9, and the square root of 9 is 3. And I want to know, does that equal negative 3? Well, it doesn't, and so 3 is actually not an acceptable answer. It's what we call extraneous, meaning it's an extra solution that shouldn't be there. Then if we try 12 minus 6 equals, it equals the square root of 3 times 12. This is the second version. So 12 minus 6 is 6 equals, this is the square root of 36, which is 6 equal to 6. That checks. And so 12 is an acceptable answer. I need to check from 34 through the end of the assignment to see if I have extraneous solutions, because we're squaring x. As soon as we square x itself, we have a potential for extraneous solutions. The last problem on the assignment is number 52, and it is a little bit challenging. We did a problem similar to this in class, but we're going to look at this one individually and try to solve it. Step 1 was to isolate the radical. Well, I have two radicals in this problem. Which one do I want to isolate? Well, it really doesn't matter. I know that if I move the 4 this way, I'll end up with a negative 1. If I move the 3 this way, I'll end up with a positive 1. And I'd prefer to work with positives, so I want to minus 3 from both sides to get the square root of 5x plus 6 equal to the square root of 3x plus 3 plus 1. Step 2 is to insert parentheses. And since that's the isolated piece, I will put parentheses over here. And then step 3 is to square both sides and FOIL. Well, this will cancel, leaving me with 5x plus 6 equal to square root of 3x plus 3 plus 1 times the square root of 3x plus 3 plus 1. We have to write it out this way so that we can get the correct foiling done. Now, some really interesting things happen. When I do the first two multiplied together, if I were to take the square root of 7 times the square root of 7, I would get 7. In essence, the square roots cancel themselves, and I'm left with the interior. So the square root of this times the square root of itself again gives me 3x plus 3. Then I need to go through the other steps. This is 1 times 3x plus 3. This is 1 times the square root of 3x plus 3. If I add 1 plus 1 in that process, I'm going to have two of them. I'll get 2 times the square root of 3x plus 3. And then last but not least is the 1 times 1, which is plus 1. All right, to finish this problem, I need to continue the process of isolating my root back to step 1. So I'm going to minus 3x from both sides. And then I've got a 3 and a 1, that's 4, so I'll minus 4 from both sides. Leaving me with 2x plus 2 equals 2 times the square root of 3x plus 3. Well, I'd like to divide by 2. If I do that, I have to divide everything by 2. Leaving me with the square root of 3x plus 3 is equal to, and if I divide into both of these, I end up with x plus 1. Step number 2, now that I've got it isolated, is to put in parentheses, and step 3 is to square both sides. So this becomes x plus 1 times x plus 1 equal to the square root. Sorry, whoa, we used the square root. Let me back that train up. It is equal to 3x plus 3. I need to go ahead and FOIL here, and that's x squared. I've got 1x and 1x, that's plus 2x, and then 1 times 1 is 1, so plus 1 equals 3x plus 3. Well, I'd like this to equal 0, so I'm going to subtract 3x and subtract 3 from both sides to get x squared minus x minus 2 equals 0. That leaves me with x and x plus and minus. Factors of 2 that have a difference of 1 are 2 and 1. I need the bigger value to be negative so that I get this, which tells me x can equal -1 or it can equal 2. Now I need to check both of those answers to make sure that neither of them make me go astray, so I'm going to grab my original problem, which is here in black. I know I've got a little bit extra here. But we can get rid of these guys here real quick. Let's look at this original problem and try to do some substitutions for me. If I use -1, that's square root of -5 plus 6, that's square root of 1, that's 1, plus 3, that's 4. Over here I have a -1, that's -3 plus 3 inside of that root, that's 0, and the square root of 0 is 0, plus 4 is 4. So this one checks out. Good. Now I want to check it again, but this time I want to check it for +2. Now, we've seen lots of times, and hopefully by the time you've done this part of the assignment, you'll know that lots of times we only have one correct answer. In this case, I think we're actually going to have 2. So I'm going to have the square root of, what's 2 times 5? That's 10 plus 6 is 16. That's 4 plus 3, that's 7. Over here, 2 times 3 is 6, plus 3 is 9. Square root of 9 is 3 plus 4, that's 7. Both of them checked out, so all of them are my answer. Okay? Hopefully that'll help you get through the assignment. I know that towards the end of the assignment it gets a little bit overwhelming to have to do this twice in the process, but you know, the assignment overall is pretty easy. I think you'll be able to grasp it and get through the work. Okay? Good luck and have a good day.